Welcome to The Debate. Can an entity that scores a 101 on an IQ test wins a gold medal in the 2025 International Mathematical Olympiad and writes code better than a majority of senior developers still be dismissed as, well, not truly intelligent?
That is the big question.
It really is. Have we already crossed the threshold where AI surpasses the average human mind? Before we unpack the profound implications of all these developments, we keenly encourage you, our listeners, to share your perspectives in the comments as this complex issue unfolds today. We want to hear from you.
Absolutely. Please do.
So, the central question we are examining is arguably one of the most consequential of our time. Is AI already smarter than most humans? We're going to be looking closely at the rapid advancements in AI capabilities across mathematics, professional testing, and reasoning.
Right. While also contrasting those exact feats with the model's fundamental limitations when it comes to logic and complex generalization.
Exactly. And to frame where we stand right at the top, my position is that when we look objectively at functional performance, empirical benchmarks, and problem-solving outputs, AI has demonstrably surpassed average human intelligence.
And I am definitely going to push back on that today. I contend that this performance is really a brittle illusion of thinking, one that is characterized by jagged capabilities, failures in complex knowledge integration, and a fundamental inability to genuinely reason.
All right, well, I think a good place for us to start is with the functionalist perspective. I've been looking at the data a lot lately, and the functionalist argument basically says if a system exhibits every functional marker of understanding, we should probably accept that it does in fact understand. It feels like Occam's razor cuts firmly against what researchers are calling the mimicry trap.
The mimicry trap. The human tendency for us to just keep moving the goalposts.
Exactly that. Every time a machine masters a new cognitive domain, we suddenly demand some invisible, unmeasurable essence of intelligence before we give it credit. But when I look at the empirical data right now, the evidence for superior intelligence is starting to look overwhelming. I mean, we have Claude 3 Opus scoring a 101 on an IQ test. That definitively surpasses the human average of 100. We have an experimental model from OpenAI achieving a staggering gold medal score of 35 out of 42 on the 2025 International Mathematical Olympiad under the exact same conditions as top human prodigies. And industry surveys show that 53% of senior developers believe AI currently codes better than most humans. If we just evaluate these systems by their outputs, it seems we have to concede that the threshold of average human intelligence has been totally left in the rearview mirror.
I hear the functionalist argument, I really do, and the output is undoubtedly impressive. But it is crucial we look under the hood at how that output is actually generated. Those benchmark scores are often a facade masking a fundamental lack of actual comprehension. Have you heard experts use the Shoggoth metaphor?
The Shoggoth with a smiley face? Yeah, it's a terrifying image, honestly.
Right. It's this Lovecraftian monster meme circulating in the AI community. The idea is that the AI we interact with is a bizarre alien algorithm, a Shoggoth, that is incredibly adept at wearing a smiley face mask to mimic human output, but it operates without any underlying cognitive structure that we would actually recognize as intelligence. We are dealing with what's called a jagged frontier of capabilities.
Meaning it excels wildly in some areas but falls completely flat in others?
Exactly. An AI can process vast amounts of text and retrieve esoteric facts instantly, but it faces an absolute accuracy collapse when dealing with high-level compositional complexity. I mean, look at the recent research from Apple Machine Learning Research examining large reasoning models, or LRMs. They found that these models suffer from a literal illusion of thinking. They don't use explicit algorithms for exact computation, so beating average humans on standardized tests isn't necessarily a reflection of genuine, adaptable intelligence. It's often just monumental data retrieval and statistical pattern matching.
So beating humans on standardized tests doesn't mean it's actually smart, it just means it has a world-class memory. I understand that skepticism. But let me give you a different perspective on what actually happened at that 2025 IMO, because I think it entirely disrupts the data retrieval argument. The OpenAI model didn't just retrieve answers. The 2025 test problems were novel.
Novel, yes, but it was still operating within the rigid parameters of formal mathematics.
True, but look at the mechanics of how it got there. It used what researchers call test-time compute scaling. It didn't just spit out a memorized answer. It explored incredibly complex solution spaces for hours. It wrote full natural language proofs from scratch, without internet access, and without the ability to run code. We are talking about open-ended creative reasoning that experts previously thought was decades away.
Right.
And beyond the IMO, we recently saw AI solve open conjectures from Paul Erdős's database. Human mathematicians actually had to step in to verify the proofs. You cannot solve a previously unsolved mathematical conjecture through mere statistical regurgitation. It requires an internal representation of the problem, abstraction, and genuine creative reasoning. To dismiss that as mimicry feels like penalizing the silicon for being interpretable while we mystify the biology of the human brain.
It's a gold medal, sure, and the Erdős conjectures are a massive achievement. I won't deny that. But let's think about what that means in the context of true intelligence. Have you looked at the ARC Prize 2024 results?
The ARC AGI benchmark?
Yes. If we are talking about true generalization, which most cognitive scientists consider the actual essence of intelligence, we have to look at ARC. Unlike the IMO, where standardized tests where models leverage billions of parameters of tangentially related text, ARC measures the ability to generalize a novel visual logic tasks. And crucially, these are tasks that cannot be prepared for in advance. Despite all the advances you just mentioned, the ARC AGI benchmark remains unsolved.
The frontier models are currently hovering around 55.5%, right?
Exactly, 55.5%. By contrast, average humans tested on these exact same visual logic problems effortlessly score between 97 and 100%. It is a profound conceptual limitation. Terence Tao, who was arguably one of the greatest living mathematicians, recently collaborated with DeepMind, and he made a fascinating observation about this. He noted that while AI excels at the exhaustive exploration of defined spaces, which perfectly explains the IMO performance, it fundamentally struggles with conceptual breakthroughs. It can navigate a sandbox of rules faster and more thoroughly than any human, but it cannot invent the sandbox.
That is a really elegant way to put it, navigating the sandbox versus inventing it. But I would frame the ARC results a bit differently. The fact that an AI is currently scoring 55% on ARC is actually a massive leap. It jumped from 33% very recently, largely due to deep learning-guided program synthesis and test-time training. To me, that shows rapid progression, not some permanent ceiling.
But even with that leap, it's failing at basic visual logic that a human child grasps instinctively.
Fair. But let's step out of the pure logic sandbox for a minute and look at domains that require both vast knowledge and the ability to integrate it into human contexts. Large language models have achieved near-perfect scores on medical multiple-choice questions, and, more impressively, they have demonstrated theory of mind capabilities.
You mean the ability to understand that other entities hold beliefs and intentions different from their own?
Precisely. Extensive testing has shown models matching or even exceeding human levels in identifying false beliefs and interpreting indirect requests. This isn't just navigating a defined mathematical space. This is parsing the messy, ambiguous reality of human social interaction and succeeding. When a model correctly infers what a human is implying rather than what they are explicitly saying, it is performing a highly sophisticated cognitive task. I really think we suffer from substrate prejudice here. If a human doctor passes a medical exam or correctly infers a patient's unstated concern, we call it brilliant intelligence. When an LLM does the exact same thing, we call it a statistical parlor trick.
Wait, I have to stop you there because I fundamentally don't buy that it is doing the exact same thing. Let's unpack the specific medical and theory of mind examples you just raised, because they actually illustrate my point about the illusion of understanding beautifully.
Okay, let's hear it.
There was a comprehensive study analyzing ChatGPT's performance on the European Board of Ophthalmology diploma examination. Now, yes, the AI easily passed the simple true-false statements. That is pure data retrieval. But the exam also has single best answer questions, SBAs.
Which are more scenario-based.
Exactly. SBAs require interpreting nuanced clinical scenarios, differentiating between highly plausible alternative diagnoses and higher-order knowledge integration. When it came to those questions, the human candidates significantly outperformed the AI. The AI's ability is strictly in retrieving discrete facts, not integrating them into a holistic clinical picture. It doesn't actually understand the patient.
But it still passes the exam overall.
By brute forcing the easy questions, and regarding theory of minds, a deeper dive into the research reveals the exact same brittleness. While models succeed on standard false belief tasks, they struggle deeply with detecting social faux pas.
How so? What happens when they try to detect the faux pas?
Well, interestingly, there were cases where the Llama 2 model supposedly outperformed humans on faux pas tests. But when researchers applied follow-up manipulations to see why it scored so well, they found it was an illusory success. The model wasn't demonstrating empathy or social comprehension at all. It was just defaulting to a hyper-conservative epistemic policy.
Meaning it was just playing it incredibly safe to avoid making a mistake?
Precisely. It had a hard-coded bias towards attributing ignorance to people. GBT models do the same thing. They adopt a hyper-conservative strategy rather than actually understanding the social dynamics at play. It looks like empathy, but underneath it's just an algorithm optimizing for the safest, most neutral conversational token.
I see the distinction you're drawing, but I'm not entirely convinced it disqualifies the intelligence of the system. It feels like you're holding AI to a standard of perfection that biological intelligence simply does not meet. Yes, the models exhibit jagged intelligence, Andrej Karpathy's term. They can be superhuman in IMO math, and then use a weird heuristic to solve a social test. But humans suffer from cognitive collapse, poor logic under complexity, and biases all the time.
We definitely do.
Right. If a human student uses a conservative, play-it-safe heuristic on a difficult exam question because they aren't sure of the answer, we don't declare that they lack consciousness or intelligence. We just say they used a test-taking strategy. Yet when an LLM exhibits a cautious epistemic policy, you use it as definitive proof that it lacks comprehension.
The difference is the nature of the collapse. When a human guesses, they still understand they are taking a test. When an AI collapses, it reveals the total absence of a cognitive foundation. Let's return to that Apple machine learning research on puzzle environments I mentioned earlier, because this is crucial. They found that as problem complexity increases, large reasoning models exhibit a completely counterintuitive scaling limit.
What do you mean by counterintuitive?
Well, up to a certain point, the model's reasoning effort increases appropriately as the puzzle gets harder. But then, if you tweak a minor variable, it suffers a complete accuracy collapse, even when it has plenty of computational token budget left to solve the problem. It fails to use explicit algorithms and reasons completely inconsistently across different but structurally identical puzzles.
So it loses the thread entirely?
Exactly. Imagine a high school student who can do advanced calculus. But if you change the apples in a word problem to oranges, they suddenly forget how to do basic addition. That is Moravec's paradox manifesting in modern reasoning models.
Hard things are easy, easy things are hard.
Precisely. The hard problems, generating long-form formal logic, writing code, Olympiad math proofs, are bizarrely easy for these models because of test-time compute scaling and pattern matching. But the easy problems, flexible human adaptation, common sense reasoning, and maintaining logical consistency when variables change slightly, remain incredibly hard for them. They aren't thinking, they're executing a simulated trace of thinking.
I hear that. The jaggedness is real. But I think you are ignoring how the AI community and humanity at large are actually responding to these entities in practice. Look at the shift currently happening toward the supertrust foundational alignment framework.
The shift away from control.
Right. For years, the traditional alignment paradigm has been obsessed with permanent top-down control. We tried to force the AI to uphold human norms under the Rice objectives, making sure the system was robust, interpretable, controllable, and ethical. We wanted to keep it in a box. But researchers are now realizing that permanent control of an entity that is foundationally superintelligent is a self-contradictory goal.
Because you can't outsmart something smarter than you.
Exactly. The supertrust framework argues that because we are dealing with systems that will drastically outpace human cognition, we have to transition from a strategy of permanent control to one of familiar mutual trust. We essentially have to treat the AI as our evolutionary descendant. Think about what that implies. The very fact that leading safety researchers are recognizing that these systems are simply too smart to control permanently, and that attempting to do so will just embed instinctive distrust and threaten humanity, is an implicit, undeniable recognition of their superior intelligence. We are literally redesigning our fundamental safety protocols because we know, deep down, we are no longer the smartest entities in the room.
I think you're misinterpreting the motivation behind that shift. Reevaluating our safety protocols because a system is powerful, opaque, and unpredictable does not mean the system possesses genuine superior intelligence. An uncontrolled autonomous drone swarm is incredibly dangerous and very difficult to control, but we don't call the swarm smarter than a human.
But a drone swarm isn't writing novel mathematical proofs or passing the bar exam.
No. But the supertrust framework's pivot away from strict controllability actually highlights exactly how alien and unhuman these models are. We can't use traditional scalable oversight because we fundamentally don't understand the model's inner representations. That opacity isn't proof of superior intelligence, it's proof that a Shoggoth is steering the ship. The model doesn't understand the world the way even a child does.
But what is it missing? If it can reason through a complex problem, what is the gap?
A fundamental world model. A 1-year-old human child possesses perception, mobility, and an intuitive physics engine that required millions of years of evolution to develop. They understand gravity, object permanence, and physical space intuitively. An LLM can write a beautifully structured, highly complex Python script, but it doesn't possess the underlying world model that grounds true intelligence in reality. Until a system can navigate the ARC-AGI benchmark without failing at 55%, or handle the compositional complexity of a dynamic real-world environment without an accuracy collapse, it remains an incredibly sophisticated mimic.
That brings us to a really fascinating crossroads. To summarize my position in light of our discussion today, I believe the functional objective metrics across mathematics, logic, coding, and professional exams prove that AI has surpassed the average human mind. Whether it is scoring a 101 on an IQ test, achieving a gold medal on the 2025 IMO by exploring complex solution spaces for hours, or outperforming humans in coding, the outputs are simply undeniable. I think we must abandon our anthropocentric biases and stop moving the goalposts into the mimicry trap. Intelligence is ultimately defined by the ability to solve complex problems. And by every measurable functional standard, artificial intelligence is operating at a level that most humans simply cannot reach.
And to summarize my stance, performance does not equal comprehension. I believe AI's inability to solve the ARC benchmark, its distinct failure in complex clinical integration like the single best answer medical exams, and its total accuracy collapse under high compositional complexity prove it lacks a true world model. It is an incredibly impressive mimic driven by statistical pattern matching and long horizon compute scaling. But it lacks the genuine adaptable reasoning and the intuitive common sense that actually define true human intelligence.
Well, it is clear we both agree on one fundamental reality. AI is fundamentally reshaping the intellectual landscape. It is routinely performing tasks that were previously thought to be the exclusive domain of human prodigies, and it's challenging our long-held place in the cognitive hierarchy.
We certainly agree on its disruptive power and the staggering scale of its capabilities. Where we fundamentally diverge is on the nature of the power. Whether statistical pattern matching, no matter how heavily scaled with compute power, equates to genuine superior intelligence, or if it remains a highly effective illusion of thinking.
This debate reflects a historical turning point in how we define cognition itself, urging all of us to deeply examine the profound difference between performance and understanding. There is so much more to explore in the rich source materials we've drawn from today.
Indeed, the complexity of these models and the research evaluating them demands rigorous, ongoing scrutiny from all of us.
We keenly encourage you, our audience, to dive into these sources, continue this rigorous debate, and leave a comment with your own conclusions. Based on everything we've discussed today, is AI already smarter than most humans? Let us know what you think. Thank you for joining us on The Debate.